Okay. Assalamu alaikum. This is the first class for M1 for both of you, Edexcel and the CI ones. And for today's class, we would be starting off with forces and equilibrium. This is your M1. So I know that most of the things over here would be coming in from your IGCSEs or GCSEs or the AS level physics that you have done. So I don't know how good you people are in physics, but every topic that we would start from would be from the basics, very very basics. So if you have any questions from the basics, just ask me. Okay, it's okay. So the first topic, this is forces and equilibrium. Forces, everyone knows force is a vector vector quantity. What is a vector quantity? A mass.
A quantity that has a direction.
That has a direction
A magnitude.
and one more thing.
Magnitude. Yeah.
And kya?
Magnitude.
Magnitude and one more unit. Force is a vector quantity. This means it is a it has a direction, it has a magnitude, and it has a unit, right? For example, and it is represented by an arrow. Any vector quantity, not just force. Any vector quantity can be represented by an arrow, right? Everyone knows about this. This is something we have done in IGCS. So this is, let's suppose, an arrow. So the tail of the arrow, what does it denote to? What does this mean? Does anyone know? The tail. What does the tail tell you about the uh what do we say? The vector, any vector quantity.
The starting point.
Mm-hmm. It tells you about the anyone, no one, Nadia. It tells you about the magnitude of the vector. A shorter arrow with a smaller tail has a lower magnitude, and and an arrow with a larger tail, a longer tail, would have a larger magnitude. What do you mean by the magnitude? Anyone? क्या नाम है? Abdul Wase. What do you mean by magnitude?
Their magnitude is the quantity or the value of a
हाँ, सही है. Good. Quantity. तो वो कितना बड़ा? Is it 10 Newton or is it 20 Newton or 100 Newton? So magnitude. And this arrow, the head, this tells you the direction. This gives you the direction. Okay. Then we have done vector addition in our IDCSEs. Addition of vector quantities. Addition of vector quantities. And the method that we used to apply, is the head to tail rule. Head to tail rule or the parallelogram method. Both of them are very similar. The methodology is the same. Parallelogram. And when we add the vector quantities, what is the answer? What do we get after we do the head to tail rule or the parallelogram method? What do we get? There's a specific name for the new vector that we get. Anyone can recall?
Is it a resultant force?
Yeah, good. Resultant vector. Right now we're just working on the generalized vectors. Okay, we'll move on to the force things next. Vectors is for every other. For example, displacement is a vector. What else is a vector? Pressure तो नहीं होता. और क्या होता है vector? Displacement, velocity is a vector. Acceleration is a vector. So whenever you add up vectors, the final effect of all of the vectors, it is called the resultant vectors. For example, there is a what do we say? A boat, and this boat is being pulled by another board from here and then another board from here. Okay, let's suppose with 1000 Newton from here and 2000 Newton from here. Definitely the board would not start moving in this direction, nor it would move in this direction. It would move in the direction of the resultant force, which would be the sum of these two vectors. Isn't it? ऐसा ही होता ना? The effect that any vector would have on an object would be always the resultant vector. Resultant vector always affects the properties of the, what do we say, the object. So this won't start going in this direction or in this direction. It would start going in the direction of the resultant vector, which you might need to find out. They might ask you to find the resultant vector over here. So this finding the resultant vector is a very important thing. So this head to tail rule and parallelogram method, we don't use that. There's another rule. There's not a specific name for this rule, but there's more important, more applicable. You will see. What do we do is, now we are moving on to the forces. Okay, finding resultant force. This is the, moving on to the next thing, finding resultant force. This is how you will work with finding resultant force. For example, now this, I'll take an example. This is a point, and on this point there is a force acting over here. Let's suppose this is 20 Newton, and it is acting at an angle of 45 degrees. And there is another force, let's suppose this is over here. Not a very good line. Like this. And this is, let's suppose, what can we do? Let's suppose this is 17 Newton. They ask you for the resultant force. Now you can use the head to tail rule and the parallelogram method. It's up to you. It's up to you. You won't get the wrong answer. But the new method which we learn now is more applicable, and I think when you will do a lot of practice, you will get a more better hands-on, you can say, you will learn this better. It's an even better method. What do? We have two vectors, the 20 Newton and the 17 Newton. Both have different directions, and this is the object A. Okay, this is the object A on which these two forces are acting. So step one, you break down the forces into X and Y components. Into X and Y components using trigonometry. Simple Sogatoa. You will see how. Now what do? This thing I'll have to explain first of all. Then we'll move on to the next thing. Over here, we can work over here. Let's suppose there is a vector like this. This is 100 Newton, and it is at an angle of 20 degrees with the horizontal. Now if I break it down into two vectors, the horizontal component would be something like this, and the vertical vector would be like this, the vertical component and the horizontal component, and both of these would be perpendicular to each other. This is the force, and this is the x coordinate, what do we say, horizontal component of the force, and this is the vertical component of the force, and this is the resultant force, you can say. So if you see that if you apply the head to tail rule, look, the head of the tail of the first vector and the head of the last one, when you join that, you get the resultant vector, isn't it? So the sum of these two would be this vector, which was 100. So we are going in the other direction. We're moving in the opposite direction. We don't have these two vectors, and we are finding this out. We have this vector, the resultant vector already, which is 100 Newton, and we are breaking it down into this horizontal component and this vertical component. And for that, what do? We use simple Sogatoa. So if I use the cos theta right now, so cos 20 is equals to adjacent, which is horizontal component, upon hypotenuse, 100. So this would give me the horizontal component, which would be 100 cos 20. Use your calculator, get me the answer. Fast. Anyone? Let us calculator. No one?
93.9.
This is giving me 93.97 Newton. And now if you break it down to the using sine theta, so sine 20 is equals to opposite, which is this is the vertical component, upon hypotenuse, which is 100. So 100 sine 20 would give you the vertical component, which would be how much? This is 34.2, I think. 34.20 Newton. So now you have broken the 100 Newton into these two components, into the vertical and the horizontal component. Okay, so this is your final answer. You have broken it down using SOHCAHTOA, simple SOHCAHTOA. So this is 93.97 and this is 34.2. And if you would use them back together to use the simple Pythagoras theorem, you will get that same 100 again. Look over here. Pythagoras, if you use the Pythagoras theorem, 93.97 is squared plus 34.2 squared. So look, you're getting the same answer, 100, 100.00045. We haven't used the exact answer, so that's why we're not getting a fully exact 100, but it's the same thing. So look, this is the new thing. This is how you break down your any vector into its horizontal and vertical component. So most of the time, you will see that the component which is with adjacent to the angle, you would use cos, and the component which is opposite to the angle, you would use sine. You will see this. For the adjacent one, use cos. For opposite one, use sine. Now we use the same logic over here. Now we have to break down all components into the horizontal and the vertical components. So how do we break it down? The 17 Newton is already only horizontal, so the vertical component for that 17 Newton is 0. We have to break down this 20 Newton into the horizontal and the vertical. So this would be the horizontal one and this would be the vertical. So for the horizontal, I would be applying cos. This would be 20 cos 45. And for the vertical, I would be applying, because it is opposite to the angle, it would be 20 sine 45. And there is only the horizontal component of 17. Only horizontal component. So this is the first step. Any questions over here? How to break down the components? Break down into components. Anyone? Ammaz, Murtaza, Nadia, Nuba, Abdul Wase.
Yeah.
Okay. Next step. Use sign convention and find sum of horizontal components and sum of vertical components. What is sign convention? Sign and convention is again very, I think that you must have heard it before as well. The coordinate system, very simple. To the right side, you take all values to be positive. To the left side, all values negative. Upside, all positive. Downside, all negative. So for all of the arrows, you see the arrows, I would take this component as positive 20 cos 45 because it is going to the right side. But this one, I would write minus 17 because it is to the left side. So I use the sign convention. This is up to you. This sign convention is up to you, whatever that you want to choose. But this is, you can say, the standardized sign convention. So it's better that you use this. Okay. So you take everything which is going to the right side positive, everything to the left side negative, everything that is going up positive, and everything going down is negative. So I will use the minus and plus according to the direction that they're going in. Now, summation of horizontal components. The first horizontal component you can take is 20 cos 45. This is positive 20 cos 45 because it is going to the right side. And then there's another horizontal component as horizontal vector as well, which is 17. But that is going to the left side, so I would do negative 17. This is the sum of the horizontal components. Then you do the vertical components. There is only one which is vertically above, which is 20 sine 45. Okay, so this is the total sum of in the horizontal direction. You're just adding up the vectors. This is the same thing. You're adding up vectors. Look, when you broke them down, now you're adding up in the horizontal and the vertical direction. The next thing, is find FR. FR is the resultant force. Resultant force using, we'll see the formula for that. And angle as well. Direction, angle for the direction, because this is a vector. You are finding the resultant vector. Vector is always, it has a magnitude and a direction as well. And for the direction thing, we find an angle as well and then give it a reference from where is this angle being taken. So for the resultant force, what do? You have the same formula, the Pythagoras theorem, which you applied over here. Look, when you did the Pythagoras theorem for the horizontal and the vertical, you found this FR, if you found this FR, right, when you did the Pythagoras theorem. So it's the same right angle triangle that you're forming over here. So FR would be simply under root of summation of horizontal components squared plus summation of vertical components squared. So this would give you your FR to be, use your calculator. First you'll have to find these values. 20 cos 45 minus 17 minus 6.494, and this would be 20 cos 45, which is 10.506 Newton. Now you use them over here. Minus 6.494 squared plus 10.506 squared. Use your calculator now. Under root minus 6.494 squared plus 10.506 squared. So this is your resultant vector. 12.4 Newton. 12.4 Newton. This is the magnitude right now. This is the magnitude of the resultant. We don't know the direction yet. Now, how would you get the direction? How would you do? We know the sum of the horizontal and the sum of the vertical. From your point A, the sum of horizontal on the left side, right? Minus 6.494. And vertical is positive, so it was over here. 10.506. So this is the vector that we have just found out, the magnitude. This is 12.4. We have found this out. This is the resultant magnitude. Now we need the angle. For the angle, what can we do is, we find this angle theta. Find the theta. That would be simply, you can use SOHCAHTOA. You can use tan theta. So for this angle theta, you would use tan theta is equals to opposite. Opposite is the height, which is 10.506 divided by base. Base is 6.494. So you find your theta, which comes out to be, use your calculator, tan inverse of 10.506 6.494. So you get in degree mode 58.3. So you would write this down, that your resultant vector, the resultant vector is 12.4 Newton, and it is 53.3 degrees anti-clockwise from negative x-axis, negative x-axis. You can say it like that. This is your final answer. Complete everything that you have given for the resultant vector. Look, so you gave the magnitude of the resultant vector, and you also gave the direction which it is in, the angle, and from where that angle is being measured. It is being measured. You are going anti-clockwise from the negative x-axis. Look, this is your negative x-axis, and you are going anti-clockwise. This is clockwise. Sorry, this is clockwise. This is clockwise, not anti-clockwise. Okay, it is clockwise. Any questions?
No, sir.
One more formula that you can write it down. It would be theta. It would be equal to tan inverse of f vertical upon sum of f horizontal. These are the two formulas at the end that might help you. But the reference location should also be given. Okay, the angle that you're measuring, from where is that angle being measured? That is also important. Okay, we're moving on forward. Let's do something now, but now the pace would I won't be going through so much detail, but we'll do the again. Okay, another example. Now you know the basic thing, what would be the background, why would be doing something, or another example now. Okay, they ask me to find the resultant force. Resize, let's make it larger. Okay, by a bigger diagram would be easier to understand. Okay, what do we do over here? We have to break down all of the three, the 60 Newton, the 70 Newton, the 100 Newton, this is Newton forces, into their horizontal and vertical components. So first of all, break down your components over here. This would be broken down into this horizontal 70, and this would be vertical one. So the side component with the angle, you always use cos. So this would be 70 cos 20, and this is opposite to the angle. There you would use sine. So 70 sine 20. Okay, when you break it down over here, this would be the smaller one, and this would be the vertical one. So this one, you can break it down like this as well. Okay, in the other direction over here. Sorry, like this. This is the vertical one, and this would be the horizontal one. Look at my arrows which I'm drawing. This is again with the angle. So this would be 60 cos 15, and this component is opposite to the angle. So this would be 60 sine 15. Now you break down this one like this and like this. So this would be, this is again with the angle, so 110 cos 50, and this would be 110 sine 50. You broke down, you worked on the question. Okay, you don't need to do excessive working. Try to do smart work. Okay, you now know what do you have to do. So try to concise your working, because this is a very simple topic. This is not very hard. So not let's not complicate things over here. So you worked on your diagram. Now you have every other component that you have found. The next step, you find your summation of horizontal components, and then you would find your summation of vertical components with the proper appropriate directions as well. Sorry, the sign convention. So I take this one as the first one. Okay, this is in the positive direction, so 70 cos 20. Then I take this one. This is again horizontal, but it is going on the left side. So this would be negative 110 cos 50. And this is also going on the left side. Look at the direction. So this would be also negative 60 sine 15. Use your calculator. For the vertical one, this is the first vertical one. Again in upward, it's going upward. So you would do it positive 70 sine 20. Then this is also upward. So plus 60 cos 15. Then minus for this one because it is going down. Minus 110 sine 50. Now use your calculator. You have broken down the into components and now you're adding the all of the horizontal ones and the vertical ones. So 70 cos 20 minus 110 cos 50 and minus 60 sine 15. So you're getting minus 20.457 Newton in the horizontal direction. For the vertical one, 70 sine 20 plus 60 cos 15 minus 110 sine 50. You're getting minus 2.368 Newton. Now, if you draw up the summations of the horizontal and the vertical, this is your point. This is your original point, right? The point A, let's suppose this is your point A. So the horizontal summation is on the left side, not negative. So it is negative somewhere here. It's a negative negative 20.457 and negative 2.368. So you're slightly going down. Negative 2.368. And this would be the resultant. This would be your resultant. And you would need again Pythagoras. So Pythagoras of negative 20.457 squared plus negative 2.368 squared. And this is how much you're getting? 20.593 Newton. And the angle, measure this angle. This would be tan inverse of vertical upon horizontal. So vertical is negative, positive. Don't consider the negative positive over here. 2.368 divided by 20.457. So tan inverse 2.368 divided by 20.457. You're getting 6.6 degrees. So the final answer you would give that the resultant force is 20.6 Newton and it is 6.6 degrees anti-clockwise from negative x-axis. This is your final answer. That's it. Okay. Now the question can be as simple as this. Otherwise, the question can be an application as well, a real-time application. For example, just like I told you about the real-time application of the boat. The boat was being pulled by two forces, 1000 Newton and 2000 Newton in different directions. And they were asking for the resultant force on the boat. That is a good example. Otherwise, another one is I think they can discuss about a truck as well. A truck which is being pulled in different directions, and you need to find the resultant force on the truck. And otherwise, more commonly, you have ropes. For example, there is a pulley through which the rope is being pulled, or there's a ring through which the pulley is being the rope is being pulled. So in different directions, your force is being applied. So they ask you to find the resultant force. But the concept is the same. The working, the mechanism, the breaking down in the components, and everything is the same. We just need to understand the question, the application, and working is the same as this, everything. Whenever they ask you to find the resultant force, try to work on the diagram. Okay, it will decrease your working. Coplanar forces. Does anyone know what do you mean by coplanar forces? No one. Coplanar forces means that the forces are in the same plane. For example, all forces are horizontal. All of these are in the horizontal page plane in the 2D like this. Okay. So coplanar means they're all in the same plane. There isn't a force. For example, there is a truck over here, and there's a force like this, and there's another force like this, and the third plane, the vertical plane as well. Look, you will get a component in the vertical component as well. So all of the forces on the truck are in the same plane like this, or sorry, let's suppose this is a truck. So all of the forces are like this, either like this or this. They are not vertical. Okay, there is no component of the force in the third plane, third axis. So these are called coplanar forces. So the forces are given to you: 250 Newton, 100 Newton, and 300 Newton. Okay, shown in the resultant of the three vectors. Sorry, the three forces are there's a magnitude of r and x at an angle of alpha anti-clockwise from the magnitude of 100. So first of all, we will have to break this down into its components. So the 100 Newton is already horizontal. You cannot break it down. 300 Newton is already vertical. You cannot break it down further. The 250 Newton can be broken down into its horizontal like this and in the vertical like this. So the component which is opposite to the angle, this is sine. So 250 sine 70, and this would be 250 cos 70. Now you add up in the sigma fh, you find your sum of the horizontal components. There are two horizontal components, both of them in the right direction, in the right side. So 250 cos 70 plus 100. And in the vertical direction, you have 300 Newton upwards and minus 250 sine 70 because it is downwards. So what do you do? 250 cos 70 plus 100. This is giving you 185.51, and 300 minus 250 sine 70. This is 65.8. So the resultant one has horizontal of positive 185.51 and vertical of 65 something vertical, so goes up. So this is the resultant force, right? For which you would have to apply the Pythagoras theorem. Both are positive. So look, I moved in the right direction, I moved in the up direction. So under root 65.08 squared plus 185.51 squared. 196.6. This is the R. 196.6 Newton. And they are asking you for the angle alpha, which is anti-clockwise from the force of 100 Newton. So this is your 100 Newton and anti-clockwise. So this angle, they're asking you for this angle. This is your alpha. So this would be simply tan inverse of vertical, which is 65.8, 0.8, sorry, 65.08 and 185.57. This would be your alpha. So tan inverse 65.08 divided by 185.57, which is 19.3 degrees. This is your final answer. You got 6 marks. Easy 6 marks. Okay. Any questions? Anything? Abdul Wase, Nuba, Nadia, Murtaza.
No, sir.
Easy or hard?
Everything clear, sir.
गुड. आसान है मुश्किल है?
Sir,
I
आसान है.
find it- yes,
आसान है.
Sana.
आसान है. Yes, this is आसान. But you need to do the practice, okay? You don't be overconfident. Do practice. But once you see that the questions are very repetitive, then you can skip these, because I can recall that when I did the practice of this topic, I did a lot of them initially, but then I started to realize that the questions are very repetitive. You will see there again and again the same type of question. So once I was very confident in this topic, then I left it entirely, because now I was 100% sure that there is nothing new to this topic coming in, and if there is anything that is coming again in the past papers, it's the same old thing, and I can do it 100% right. So that's why then I would skip this topic right now. Do the past papers, okay? Don't take it lightly right now, because you haven't done the question yourself. Once you do enough practice and you see the questions repeating themselves again and again and again, then I would suggest you can skip this topic, because there are other more difficult ones you'll see later on. Okay, I'll give you another one for you people to do it right now and then share it with me. Mm-mm. Let me see a difficult question. Take a screenshot for this one, or let me bring it over there. It's not that hard, but let's see. It's the first one. So okay, complete this question. This is for right now. Okay.